This is the subnetting lab that we did in NET-223. We have quite a few networks. If I was to mark those networks, we have this one we do not worry about because that one's going to the ISP. But otherwise we've got this network and they want 500 hosts there. We have this network, 400 hosts and 400 hosts on this network here. And then the networks down here, 100 hosts, 100 hosts, 100 hosts, and 100 hosts. And then also here we have the WAN networks. Here, the WAN connecting here. You would count each of these. This would be one, this would be one. Here, across here, and across here. So if we were to count all these, you could go through and count them all to know how many networks that we would have. Okay? So we're not doing variable length subnet masking. So we're just going to assign the networks based on the host for right now. So for example, 500 hosts is the largest one, so we're going to network it based on that. Knowing though, in the future you could take those and split them up. Okay? So I'm going to go to the last thing we talked about. If I go back to the first slide here, if you look at how you might divide the addresses up, if you drew a line down here, and if you put a block of addresses down on this side, and a block of addresses down this side, there's a way you could divide it up so then you could actually have one route pointing this way and one this way. And then these routers would handle dispersing it down inside the network. And we talk more about that later on, especially when you have the chapter on variable length subnet masking. And that is it. Here's what we did to start with. We had this network to start with. This part right here, we can't change. We can't change that right there. So the 172, I didn't write the bits out for that, and I didn't write the bits out for the 16. But the other octets, this octet right here, and this octet right here, we can change and adjust. We can do with that whatever we want. And that's those two octets right here. The reason we know that, the /16, 16 bits. We got 8 bits here, 8 bits here. That's our 16. So now we need 500 hosts. So you have to calculate that coming across. People do it different ways. Some people would go here. They say, well, these two, that would give us 2 hosts, 4 total networks and 2 hosts. Then this gives us 8 total, 6 hosts. And then you can just keep working your way up. Okay? So it's 8. So that would be 6 hosts. This would be 16 total. 16 total. And so that would be 14 hosts. 32 total. 30 hosts. 64 total. And then that would be 62 hosts. 128 total. 126 hosts. 256 total, 254 hosts, 512 total, 510 hosts. So that's why we drew the red line right there. That's why we drew the red line right there. Let me show that again. We had that red line right there. Another way you can do this, all these bits, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 to the 9th should be 512, and then we subtract 2, 1 for the network, 1 for the network, and 1 for the broadcast. Okay? So you could also do it that way. So that's where we divided the line. Okay? And then here, if we go back in and take a look at this, this would be our first network would be all those zeros. Slash 23, how do we get 23? Well, we have 8 and 8 are 16. And then we have 17, 18, 19, 20, 21, 22, 23. So it's a slash 23, that's the mask. If you're going to calculate the mask, you'd have 255, 255, and then you'd have to calculate those added together. So you take 128, 64, 32, and so forth, and add it up and get the mask. Okay? So that's our first network. This would be our first address. That would be all those zeros and then a 1 clear out here. And then this would be our last address. That would be all those zeros and then like a 1 here, 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 and then the last one would be a 0. So that would be 1. This one is this one, and then this would be 254. Our next address is this one, okay, and that one goes with this one, 172, 16, 2. See, we got a 1 right here, and if you look at that in terms of the octet, where that's divided, that would be a 2. Oh, excuse me, that one's a 4. That's this one down here. That one's a 4. This one here would be the 2. This network here would be this one right here. Because of the 1 right here. That makes it a 2. Okay, that makes it a 2. So then, this next one, I should probably get rid of this stuff here. This next one we have a 2, and then here's our first one, the 2, and then a 1 down here, and then here's our last one. That would be a 1 there and a 1 there, so that would be 3. It's getting to be a little bit of a mess, but that's where this 3 comes from. And then we'd have a 0 at the end, and we'd have 1s here, and it'd be 254. The next one, right here, 1 here, and a 0 here, and a 0 here. Now that's 4. A little hard to see, but that's this 4 here. And then if we keep moving, so we have a 1 here and a 1 here, that would be 6. And you could keep going. 8. And you could write out all those networks, which would be 2 to the 7th, which would be 128 networks. You could write them all out. And then you could keep writing in these, and the pattern follows. You can see how that would follow there too. Writing out those addresses. All right. So, you know, if we take a little bit of this stuff away here so we can see a little better. Okay. Now, we can see then this would keep going until we get our 128. you wouldn't have to write them all out. And then the last thing, and that's it. All right.